Hi students, this is Alex here. In this problem, they have given a string of length L has its ends at x is equal to 0 and x is equal to L, which is fixed. And the point x is equal to L by 3 is drawn aside a small distance h. And the displacement y of x comma t satisfies the wave equation. And we have to find the y of x comma t at any point t. Now let's take a small diagram. So we have x-axis and y-axis. They say a string of length L. So the one end is at 0 and other end is at L. So we take a string like this, and this is a point A and this is a point B. And now they say the point x equal to L by 3, somewhere here, it is drawn aside a small distance h. So from here it is pulled to some distance here, so it will become like this, and this distance which is pulled is h. So let's write all the coordinates. This a is 0 comma 0, b is L comma 0, this part is L by 3. So I take this point C, L by 3 comma h. So we have these 3 points. Now initial and boundary conditions, y of 0 comma t will be 0 because it is one end for all the values of t, the displacement is 0. Second condition is y of L comma t is 0 for all the values of t because it's the other end which is fixed. And dou y by dou t, that is the initial velocity when time is 0 is initial velocity, which is also 0 for x 0 less than x less than L, and y of x comma 0 is we have to find. That is, we have two parts. One is from A to C, then C to B. So we are going to use 2-point formula. So equation of AC. A is 0 comma 0, C is L by 3 comma h. So this is A and this is C, and for reference let's take x1 y1 and this is x2 y2. Now y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So y minus 0 by h minus 0 equal to x minus 0 by L by 3 minus 0. This, when we further simplify, we get y by h equal to x by L by 3. So 3 we take to the numerator, so 3x by L, and taking h to the other side, y is equal to 3hx by L. So this function is 3hx by L when 0 less than x less than L by 3. And another part is from L by 3 less than x less than L, which we have to find. It is nothing but the equation of BC. So we have L comma 0 and L by 3 comma h. So L comma 0 and L by 3 comma h. This is B and C. We are going to find the equation of BC. Y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. Now this is y by h equal to x minus L. L by 3 minus L is, after taking LCM, minus 2L by 3. There is a minus sign, and taking h to the other side, we get this 3 also will be taken to the numerator. So 3h into x minus L by 2L. There is a minus sign. I'm going to take the minus sign inside of this. So this will become 3h into L minus x by 2L. So we keep this here, 3h into L minus x, 3h into L minus x, then whole divided by 2L. So we got all the conditions, and they have given a wave equation. So the suitable solution we are going to write. So the wave equation is, the wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. So we have written the wave equation and we are going to write the suitable solution. The suitable solution is, we have y of x comma t equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Now we are going to use the first condition. The first condition is y of 0 comma t is 0. Wherever x is there, we have to put 0. So y of 0 comma t equal to, here I put 0. When I put 0 here, cos 0 is 1 and sin 0 is 0. So we have only c1 and c3 cos pat plus c4 sin pat is written as it is. And this value is 0. So we take 0 equal to c1 into c3 cos pat plus c4 sin pat. And this entire term is not 0 because it is defined for all the values of t. c3 cos pat plus c4 sin pat not equal to 0 as it is defined for all t. Therefore, the only option is c1 must be 0. So we found the constant c1 as 0. Substituting that in our solution is y of x comma t. When c1 is 0, the first term will not be there. So c2 sin px alone will be there. Then rest of the term c3 cos pat plus c4 sin pat we keep as it is. Now we are going to use the second condition, that is using second condition y of l comma t is 0. Wherever x is there, substitute l. So y of l comma t becomes c2 sin pl into c3 cos pat plus c4 sin pat, and this is 0 as per the condition. So 0 equal to c2 sin pl into c3 cos pat plus c4 sin pat. Now this entire term already we discussed, it is not 0, and c1 not equal to 0 as c1 equal to 0. Already c1 is 0. Again another constant from the same term cannot be 0. Therefore, the only option is sin pl equal to 0. When sin theta equal to 0, we have theta is equal to n pi. So this pl equal to n pi. So p will be n pi by l. So we have to substitute that in our solution. Y of x comma t will be c2 sin px. So n pi x by l into c3 cos pat. So n pi at by l. So n pi at by l plus c4 sin n pi at by l. Now we are going to use the third condition. For that we need its derivative. So dou y by dou t we are going to find, and since we differentiate partially with respect to t, x is treated as a constant. So the first term is written as it is the x term, so it is treated as a constant. Now derivative of this c3 into minus sin n pi at by l and into n pi a by l. Again c4 into cos n pi at by l into n pi a by l. So we found its derivative. Now let's use the third condition, that is dou y by dou t of x comma 0. That is initial velocity is 0. So wherever t is there, we have to put 0. So now I put 0 here. So dou y by dou t of x comma 0 equal to, so this term is C2 into sin n pi x by L. Then when I put 0 here, sin term is totally 0. So we have only C4 into, when I put 0 here, cos 0 is 1 and into n pi a by L. So this is the term remaining for us, and this is equal to 0 now. So 0 equal to C2 sin n pi x by L into C4 into n pi a by L. Now already we discussed C2 cannot be 0 and n pi a by L is a constant that cannot be 0, and sin n pi x by L cannot be 0 because it exists for all the values of x. Therefore the only option is C4 must be 0. So when I take C4 0 in our solution, already we have y of x comma t equal to C2 sin n pi by L x, that is C2 n pi by C2 sin n pi x by L. Then C4 is 0. So only C3 into cos n pi at by L is remaining. So C3 into cos n pi at by L. So we got the solution. Now both the constants are taken as a single constant Cn, and this is y of x comma t. We can also take summation from n is 1 to infinity, and we have sin n pi x by L into cos n pi at by L. Now using the last condition, y of x comma 0, we have a function here, and that function is having two parts. One is 3hx by L. So we have 3hx by L, 0 less than x less than L by 3, and another one is we have 3h into L minus x by 2L. 3h into L minus x by 2L for L by 3 less than x less than L. So I'm going to apply this. Wherever t is there, we have to put 0. So y of x comma 0 will become summation n is equal to 1 to infinity Cn, and we have sin n pi x by L. When I put 0 here, cos 0 is 1. So this term will be 1 totally. And on the left hand side, I can use this function. So this is 3hx by L when 0 less than x less than L by 3, and 3h into L minus x by 2L when L by 3 less than x less than L. This is equal to summation n is from 1 to infinity. We can take this as a Bn because it is a Fourier half range sine series. So sin n pi x by L we have. So this is a half range sine series. Let's write it here. This is half range Fourier sine series. So we can find Bn using the formula 2 by L integral 0 to L f of x dx, f of x into sin n pi x by L dx. Now let's substitute the f of x here. It is actually made up of two parts. So Bn equal to 2 by L integral, first part is from 0 to L by 3, and in this case f of x is 3hx by L into sin n pi x by L dx. Similarly, the second part is 2 by L integral L by 3 till L and 3h into L minus x by 2L into sin n pi x by L dx. So here we are going to use the Bernoulli's formula. So this part is u and this is v. So u equal to 3hx by L. V is sine n pi x by L. So u dash is 3h by L. X derivative is 1. U double dash is 0 because this is fully constant. And V1, its integration is minus cos n pi x by L by n pi by L. And V2 is minus sine n pi x by L by n pi by L whole square. In the same way, this entire term is u and this is v. So u is 3h into L minus x by 2L and v is sine n pi x by L. So u dash will be 3h by 2L into minus 1 and u double dash will be, this is totally constant, so 0. Now v1 is minus cos n pi x by L by n pi by L and v2 is minus sine n pi x by L by n pi by L whole square. Now we use the Bernoulli's formula. The formula is uv1 minus u dash v2 plus u double dash v3 dot dot dot. So we take bn equal to, outside we have 2 by L. Now this is uv1. U is 3h x by L. 3h x by L. V1 is minus cos n pi x by L by n pi by L. So we substituted V1. Similarly, minus u dash, which is 3h by L. So 3h by L and V2 is minus sine n pi x by L by n pi by L whole square. And we have u double s is 0, so we can stop here and put the limit 0 to L by 3. And coming to the next part, again we have 2 by L and u value is 3h into L minus x by 2L. So 3h into L minus x by 2L into minus cos n pi x by L by n pi by L. Then minus, and here it is minus 3h by 2L u dash. So I can make plus 3h by 2L. Then minus cos, V2, which is minus sine. So minus sine n pi x by L by n pi by L whole square. Now we have from L by 3 till L. Now using the upper limit, we have to substitute x as L by 3. So 3h by L into L by 3 into minus cos n pi into L by 3 by L by n pi by L. So first term I have substituted. Second term, this minus I can make it as plus. So plus 3h by L into sine n pi L by 3 and we have another L. Then n pi by L whole square. Then we have to substitute the lower limit. When I put the lower limit, because of this x, this first term is 0. Because of this x, sine 0 is 0. So entirely the lower limit is 0. So we have only this much. Now plus, coming to the second set of terms, I have to substitute L. So when I substitute L here, L minus L 0. When I substitute L here, after cancelling with L, sine n pi, which is also 0. So upper limit is completely 0. Minus lower limit I have to substitute L by 3. So now this is 3h into L minus L by 3 by 2L into minus cos n pi L by 3 by L, then n pi by L. Similarly, so first I put L by 3 for x, 3h by 2L into minus sine n pi L by 3 into L by n pi by L whole square. So we completed the upper limit minus lower limit substitution. Further, in both the terms we have 2 by L common. So I am going to take this 2 by L common. This and this we can cancel, this and this we can cancel. So we left with minus h into cos. After cancelling this, n pi by 3. And denominator we have n pi, and this L will go to the numerator. So minus hl I can take. Similarly, the next term 3h by L, we can cancel this sin n pi by 3, sin n pi by 3 by n square pi square, and L square I take to the numerator. So I take L square here, so we can cancel this. Then L minus L by 3 is 2L by 3, and there is a minus sign. So minus 3h by 2L into 2L by 3, and there is a minus sign, so I can make this as plus, and cos n pi by 3. So n pi by 3 by n pi by L, that L will come here. So I can carry this L to the numerator. So here we can cancel L and L, because already there is one L. This by L I take to the numerator. So it becomes L square, so L we can cancel. Even this 3 and 3 we can cancel, 2 and 2 we can cancel. So we left with only HL into cos n pi by 3 by n pi. And the last term is this minus I took inside, and again I have to take it for this. So it will become plus 3h by 2L into sin n pi by 3 by n square pi square by L square. So I take this L square here. And after that, we can notice that these two terms are same term with opposite sign. One is minus HL cos n pi by 3 by n pi. This is HL cos n pi by 3 by n pi. So we cancel this. So we left with Bn equal to 2 by L. And here, after cancelling this, we get 3HL. So totally it is 6HL. Actually, there is one 2 here, so you cannot add like this. So first let's write 3HL sin n pi by 3 by n square pi square plus 3HL sin n pi by 3 by 2n square pi square. Let me check here whether any term getting cancelled, because usually we get a similar terms. Suppose if I add this, yeah, we have written it correctly. Suppose when I add this, I make common denominator. So I put into 2 into 2. So we have a common denominator 2n square pi square. 2 by L square, and this is 2n square pi square. This is 3 to the 6, and here 3. So totally 9HL sin n pi by 3. So we can cancel this, and we can cancel this. So finally Bn will be 9h sin n pi by 3 by n square pi square. So this is our Bn. We are going to substitute this in our solution. In our solution, what we had is y of x comma t equal to summation n is from 1 to infinity Bn, which is 9h sin n pi by 3 by n square pi square. We had sin n pi x by L into cos n pi at by L. This is the place we have to substitute, and I have substituted. Cn is Bn. So after substitution, we get sin n pi x by L cos n pi at by L. And now the constants can be taken outside the summation. So finally, y of x comma t becomes 9h by pi square is a constant which we can take it outside. Now summation is from 1 to infinity, and 1 by n square we have here, and then we have sine n pi by 3 into sine n pi x by L into cos n pi at by L. This is the required solution for the given problem.